Kuala Lumpur City is experiencing a serious problem. Flooding is becoming more frequent annually. The financial district in the city has always been badly affected, with 5 major floods in the last 2 years. There is an urgent and pressing need to resolve this problem faced by the federal capital city. The root cause of these floods is from the catchments of Sungai Klang and Sungai Ampang to the east of the city. Storage ponds are the obvious and cheapest solution to resolve flooding problems. Many natural ponds are available at the Sungai Gombak and Sungai Batu catchments to cope with the increased rainfall runoff. However, the Sungai Klang and Sungai Ampang catchments are already densely developed and have insufficient natural ponds. To construct huge storage ponds in these catchments will involve very high land cost and massive disruption to the dense development that is already established. The only cost-effective solution that remains to the KL City flood problem is to construct a store and release system. This will comprise a bypass tunnel with ponds at both ends of the tunnel. The government and their consultants have also confirmed that the store and release tunnel system is the most appropriate solution to mitigate the flooding in KL City. Just as in the human body, the capacity of a person to drink is vastly different if the bladder is with a release mechanism or without. With this release mechanism, there will be less space required for storage and continuous intake of water is possible. The bypass tunnel should begin downstream after the 2 main rivers, Sungai Klang and Sungai Ampang meet. This is where maximum diversion of flood flows can be obtained to offer maximum flood protection. The bypass tunnel should end downstream and away from the city at Sungai Karayong. An ideal corridor with natural ponds upstream and downstream of the tunnel has been identified and is approximately 11.5 kilometers in length. It is fortunate that such an ideal corridor exists. This store and release system comprising the tunnel and 2 huge natural ponds has a capacity of 3 million cubic meters and is designed to be sufficient to handle the worst flood. The corridor is strategically close to the main southern gateway to the city at the Sungai Besi airfield, where there is a major traffic congestion problem daily. As the tunnel will only be used to its full capacity a few times a year for flood control, its usage on a daily basis as a motorway to ease the daily traffic congestion at this southern gateway makes good economic sense. As most of this capacity is located in the holding ponds at both ends, the incorporation of the motorway tunnel into the system only reduces the overall storage volume by 10%. The magnitude of the floods from storms vary from year to year. As such, most average-sized storms will not require the full capacity of the system to be utilized. In short, even when the motorway tunnel is in operation, the 90% balance of the capacity that is available to deal with the floods will be sufficient in a normal year. It is only in the event of an exceptional flood, when the final 10% capacity of the system is needed, that one needs to close the motorway tunnel and use the whole facility as a flood tunnel. This motorway closure is expected to occur only once or twice every few years. This way, the usage of the tunnel facility is maximized by its dual use for flood mitigation and as a motorway, while the inconveniences caused by the closure of the motorway is at the same time minimized. Hence, SMART, a stormwater management and road tunnel solution. SMART is a safe solution as the motorway users will be given ample warnings before it needs to be closed to traffic. For the operation of SMART, A flood detection system consisting of river water level and rainfall stations will be installed at strategic locations for real-time online monitoring. This system enables the early prediction of the floods and their magnitudes, detecting the need to close the motorway 2 hours in advance. The clearing of the traffic in the motorway will only take 15 minutes. Once an approaching flood is detected, the diversion gate at the riverbed is raised automatically. This controls the flow from the Sungai Klang and Sungai Ampang into the city and diverts excess flood flows into a holding pond through a diversion structure. Both the diversion gate and structure are located immediately after the confluence of Sungai Klang and Sungai Ampang that flow into the city. This is to ensure maximum diversion of flood flows. SMART is an efficient solution as the motorway can be reopened to traffic within 48 hours of closure. Flood flows often contain floating debris, gravel, sand and sediments. Particular attention has been given in the design to remove these before the flood flows are diverted into SMART. Floating booms will be placed across the two rivers. These booms will trap the floating debris. The raised bed of the diversion structure has been designed to prevent gravel and sand carried along the riverbed from entering SMART. In addition, the curtain wall alongside the diversion structure prevents any floating debris from entering SMART. Sediments carried with the flood flows are trapped at the holding pond. The baffle walls in the pond have been designed to lengthen the path of the flood flows, giving sufficient time for the sediments to settle to the bed of the holding pond. From the holding pond, the flood flows are channeled into the tunnel. At the inlet to the tunnel, trash screens are installed to further prevent any debris from entering the tunnel. The flood flows that are carried inside the tunnel will contain only very fine sediments. The slope of the tunnel has been designed to be sufficiently steep to ensure that these fine sediments do not get trapped inside the tunnel, but will instead be carried along the tunnel. Once the flood flows have receded, the motorway is cleaned using pressurized water from the hydrants inside the tunnel. The cleaning process is made easier as the walls of the SMART motorway have been lined with a non-absorbent, non-stick ceramic coating. Enzymes are also sprayed in the SMART motorway to disinfect and deodorize the tunnel. These enzymes have been successfully used in landfills and waste disposal sites in Malaysia. The motorway begins near the Sungai Besi airfield and is approximately 4 kilometers in length. It shares a common tunnel with the bypass tunnel along Jalan Chan Sao Lin before parting at the Kampung Pandan interchange. The road tunnel ends at the city at Jalan Sultan Ismail. Steps have been taken to ensure that SMART is safe for the use of the motorists. The major risks involved with this dual-usage tunnel have been identified as fire safety and water tightness. These issues have been studied by world experts and our own engineers, and they have confirmed that it is feasible, safe and practical to incorporate a motorway within the bypass tunnel using existing technology that has already proven to work. A unique feature on SMART is the double-decker motorway tunnel. With the double-decker, the traffic in each direction is separated. Furthermore, only cars will be allowed to use SMART. Hence, there is no risk of head-on collisions and severe accidents from heavy vehicles carrying inflammable materials, which was the cause of recent fires in 2 tunnels in Europe. Emergency exits are also provided at every 250 meters. At every alternate emergency exit are powerful air ventilators. Because of the double-deck arrangement, one-way airflow can be provided at each deck level. This is very efficient in keeping the air fresh within the tunnel and the blowing away of smoke in the event of a fire. Traffic control equipment are housed in special watertight casings that are resistant to the flood flows. To ensure water tightness, steel gates which are operated automatically using hydraulic systems are placed in the bypass tunnel at both ends of the motorway. These gates will be air vacuum tested periodically to ensure they are watertight for protection to the motorway tunnel. Such gates have been used in the London Underground Railway tunnels since World War II to prevent floodwaters from the Thames River overflowing into the subway system. For added safety, 2 gates will be used, although only one is needed. Motorists will find that the journey from one end of the motorway to the other takes only 4 minutes, compared with the 20 minutes they are experiencing now. Kuala Lumpur City is situated mainly on karstic limestone geology. The features of karstic limestone include cliffs, pinnacles, cavities, collapsed cavities, and sinkholes. Overlying this karstic limestone is loose alluvium from previous tin mining activities. During the construction of the LRT tunnel, incidences of road subsidence, or more commonly known as sinkholes, occurred along Jalan Ampang due to the consolidation of this loose alluvium. The tunnel boring machine used was an earth pressure balance machine. This machine was not able to prevent the drawdown of groundwater during the tunnel construction. The descending groundwater consolidated the loose alluvium, resulting in the sinkhole incidents. For SMART, we have carefully selected and specified the Slurry Shield tunnel boring machine. This machine has been designed to overcome the problems of drawdown of groundwater, which is the root cause of the sinkhole incidents. The Slurry Shield machine is not more expensive than the previous tunnel machine. Unlike the previous type of machines, the Slurry Shield is able to create a pressured shield made up of bentonite slurry. This pressure shield is able to counterbalance the pressures of the groundwater and loose soil acting on the face of the boring machine. Air is pumped in through the pipe, colored yellow, and the bentonite slurry is fed in through the pipe, colored red, into the excavation chamber to create the pressured shield. In doing so, a watertight bentonite cushion is formed in front of the tunnel excavation face that will prevent the drawdown of groundwater and will provide support to the loose alluvium. This situation of pressure equilibrium allows the machine to bore with sustained stability through all types of soil conditions. The Slurry Shield machine consists of 4 main parts. The first part is the rotary cutter head, with tungsten drill bits used for the excavation of the soil and disc cutters used for the excavation of rock. The second part of the machine is the bulkhead, located immediately behind the rotary cutter head. This is where the pressured bentonite slurry shield is formed to provide stability during the tunnel excavation. The third part of this machine consists of hydraulic rams, which are used to propel the machine forward and to keep the tunnel in its right alignment. The fourth and last main part of the machine is the tunnel lining erector. This erector is used to build the walls of the tunnel. The other parts of the machine comprise systems that house electrical, slurry pumping and ventilation equipment. The precast concrete linings for the tunnel are transported continuously to the erector by rails. These linings are then hoisted and placed in the correct position in the tunnel with the help of vacuum pads. Hydraulic arms are extended to keep the linings in place while the linings are bolted together. The void between the excavated ground surface and the linings is immediately filled with cement mortar grout under pressurized conditions to ensure all the voids are fully filled. Similar machines have also been used in the Elbe Tunnel in Germany and in the Westerschelde in Holland. For SMART, two slurry shield machines are used, both starting from the JKR field area at Chan Sao Lin. The first machine will head south, under the Jalan Chan Sao Lin and KL Seremban Highway next to the Sungai Besi airfield, before terminating at the existing pond in Taman Desa. The second machine will head north under Jalan Tun Razak and Jalan Desa Pandan before terminating at the pond at Ampang behind Gleneagles Hospital. SMART's dual purpose ensures maximum usage of the tunnel with minimal inconvenience to the motorists. The use of the specially designed slurry shield machine will ensure sustained stability during construction.